И мы рады, что у нас начинается он с методологического семинара, который посвящен теме метаанализ. И выступает у нас Мавлетова Айгуль Мавлетовна с Высшей школы экономики. Ну, регламент примерно такой, что давайте где-нибудь выступление 40 минут, 50 минут. И дальше вот у нас будет время для обсуждения. Обычно мы заканчиваем где-то вот в 7:30.
Я поняла. Можно мне?
Все, да, пожалуйста.
Я расскажу о метаанализе и, соответственно, у меня много слайдов, я надеюсь, что я успею. Первое, расскажу о том, что такое метаанализ, и расскажу о том, что это часть систематического обзора, и далее, зачем нужен метаанализ, преимущества и критика. И, конечно, есть огромные преимущества, но его сейчас, может быть, активно тоже критикуют. Расскажу о процедурах проведения метаанализа, расскажу о значениях эффекта, которые обычно используются в метааналитических процедурах. И далее расскажу о моделях анализа, их две, очень просто, fixed effect и random effects. Вот, и расскажу о том, когда выбирать ту или иную модель, а дальше расскажу, в конце, я надеюсь, успею, что нужно написать в статье, о чем нужно не забыть, если вы пишете метааналитическую работу. Ввел метаанализ ГЛАС в 1976 году, и он сказал о том, что вот всегда, как правило, нам нужно иметь доступ к базам данных, если у нас нет доступа к базам данных, что нам делать? И решение, которое он предлагает, это провести метааналитическую работу. Нам не нужно иметь непосредственно базу данных. Зачастую у нас такой возможности нет. Что такое вообще метаанализ? Да? Метаанализ – это систематический обзор, часть систематического обзора, где вы просто анализируете величину эффекта. То есть вы измеряете общую величину эффекта, по-английски это звучит effect size. Effect size – это основа вообще, о чем мы говорим в метаанализе. Какое отношение имеет метаанализ к систематическому обзору? И вообще это, конечно же, часть систематического обзора. Если вы вдруг действительно делали систематический обзор, а не просто нарративный обзор, то можно посмотреть, вы увидите, что в принципе система похожая, просто в систематическом обзоре не всегда вы имеете в виду метааналитическую процедуру в конце работе. Как правило, метод синтеза у нас неизвестен, да, то есть вы просто перечисляете то, что вы прочитали, каким-то случайным или не случайным образом, да. А если вы хотите почитать, действительно сделать статистический анализ величины эффекта, да, то это как раз вы проводите метааналитическую процедуру. Часто показывают, да, что у нас есть такой огромный байс в том, как мы цитируем работы, и мы, конечно же, цитируем работы с статистически значимой величиной, там, где было показано, что что-то имело эффект. И, скорее всего, мы можем какие-то работы упомянуть в маленькой ссылке о том, что в некоторых работах величина эффекта не была значимой. Все это делают, и такой классический пример о том, что Нобелевский лауреат в своей классической работе тоже, в общем-то, действовал по этому принципу. Он процитировал значимые работы и не указал на значимые работы. Это, в принципе, то, что мы обычно делаем. Зачем нужен метаанализ, да, метааналитическую процедуру проводить? У нас есть огромное количество исследований, и, как правило, мы не успеваем следить за тем, что вообще происходит в индустрии, и поэтому, как правило, мы обращаемся к метааналитическим работам, и в этом смысле они очень хорошо цитируются, потому что метааналитическая работа сразу, например, анализирует 100 работ, и вам ничего не надо делать, просто обратиться к этой метааналитической работе. Большая проблема, да, различия в величине эффекта, то есть всегда, как правило, особенно в экспериментальных исследованиях у вас получается разная величина эффекта, то есть где-то получается большая, где-то маленькая и так далее и тому подобное. Вот метаанализ как раз вот вычисляет эту среднюю взвешенную. Ну и, соответственно, если проводить метаанализ и как раз выбирать метарегрессию, да, то есть мы объясняем дисперсию величины эффекта, соответственно, вот третий вопрос, как измерить общий эффект вне зависимости от объекта специфики, то есть у вас есть некоторая средняя взвешенная метааналитическая, а дальше вы можете объяснить и дисперсию, то есть почему величина эффекта различается. Ну вот, зачем нужен метаанализ еще, да, то есть ошибка первого рода, то есть, когда нулевая гипотеза неверно отвергнута, да, то есть это то, что мы обычно цитируем, часто такие исследования. Вот winner's curse и publication bias тоже покажу. Publication bias, он есть везде, всегда, в любой сфере. Вот у winner's curse, я помню, даже в Нью-Йоркере была такая популярная статья об исчезающем эффекте, то есть о том, что изначально публикуются статьи с невероятной величиной эффекта, с очень большой величиной эффекта, а дальше, как правило, никто не может повторить это. Ну, это, кстати, везде так появляется, потому что мы не знаем, что было до этой публикации, например, когда эффект был большой, там куча, может быть, экспериментов было проведено, но все было незначимо, соответственно, не было хорошей публикации. Здесь хорошая публикация, и исследователи пытаются повторить, и, соответственно, как бы повторить не могут. Ну, вот winner's curse. Publication bias я сказала, и все мы знаем, что если у вас получились статистически незначимые результаты, то вы не знаете, куда податься с этой статьей, и, в общем, не знаете, что делать. Да? Ну, вот выглядит application bias примерно так, и не всегда решает, и я покажу тоже, не всегда решает эту проблему метаанализ, да, то есть как раз вот тот слева угол, да, когда у вас получается незначимый результат, у вас маленький объем выборки, да, вот таких исследований, как правило, вообще не публикуют, то есть вы их просто не заметите. Ну, опять же, publication bias, таких много всяких исследований о том, что, конечно же, публикуют с большим эффектом, если у вас небольшой эффект, то вас не публикуют. Это везде, конечно же. Ну вот преимущество и критика метаанализа. Преимущество, я, наверное, уже сказала о том, что можно измерить среднюю величину эффекта и возможно объяснить дисперсию. Я потом, может быть, покажу это лучше. Ну, критика. Сейчас, может быть, увеличилась, мне кажется, критика в сторону метаанализа. Ну, вот студенты часто вообще не понимают, как можно в одном значении все измерить. Вот они это одно значение можете суммировать, да, как бы почему должно быть только одно значение, такой вопрос. Ну, garbage in, garbage out, это как раз увеличивается критика со стороны как раз редакторов, потому что если вы включаете в метаанализ работы уже с некоторыми проблемами дизайна. Okay, yeah.
Now we have.
Now you win. Now it's your day.
Yeah, the significant critical threshold.
Tipping point.
Yeah, so now it's critical critics of meta-analysis. The problem, the problem is garbage in, garbage out, and then the publication bias. That's what I was talking about. That it cannot also solve this problem. Apples and oranges problem. So that is what usually students ask me. Also, how can we say if different experiments? How can we say that it's just one effect size? So how to conduct meta-analysis? So you need to have your research question. So that is the first point, and then you should think about the object of your research topic, and then the selection of your publications. So that is one of the main questions, and then how to code your your articles or publications, and then how to calculate the effect size, and I will talk about that. So the research question can be different, but the main point, it's usually, if you talk about meta-analysis, it's usually about experimental or quasi-experimental studies. It can be also non-experimental studies, so just mean or average, it's also okay, or variation. But usually you should ask some research question about correlation, or for instance, okay, it's about one question I will talk about that as well, about the night mass, and there is some research about that, who is more frequently having night mass, women or men, and meta-analysis shows that women, at least they report that they have more night mass. And that is, then you should think about, okay, for instance, if I talk about nightmares and females and males, and I compare them, then should it be everybody, or should it be some age groups? For instance, I say children among children, or among adults 18 plus in Russia, or in the US, and etc. So you should define what you're talking about. And then it's research selection, so how to select the publications. It's very important because it's a meta-analysis, is systematic review, so you should think about that as a representative sample, and that is very important because we think about the publication bias. So and the main thing is that you should select not only published articles, you should include definitely unpublished articles. So that is the main point. But think about that as a representative sample. So your publications are representative sample of the universe of the publications you are talking about. And that's how you can say that this meta-analytical procedure is representative. And then you should talk about, okay, yeah, I think I was talking about that. Okay, this is how you should define the publications you include, and that is very important because you have to make it very explicitly in your research how you why and how you include it in your publications in the research, and that is one of the main points in meta-analysis, because the main point is if I define the same define the same object, and if I define the same limits, can I repeat your search? So that is and also as I said, that is very important because when you write a meta-analytical publication, you should define what databases you use. It can be now it's very popular to use Google Scholar. It's okay to use it. It's okay to use only Google Scholar, and usually, but as I say, the main point is that you should describe it in very good details, so I can repeat your search strategy, and I will find the same publications. So that is the main point. And it's also, as I said, unpublished articles should be also included, and usually dissertations included, and that's proper dissertation thesis. Also, and I was included in one of that, just ask experts. I was also asked as an expert. So if you find the articles and then you think, okay, maybe I didn't find them all, you should ask experts if they think it's full or not really. So if they know about unpublished works or conferences, conference talks. So that is how it looks like. So you should include criteria. You should say about when the research should be done, like how it's usually done. Like there are a lot of meta-analytical works, and usually it is you say, okay, there are a lot of meta-analytical works, but there are not so many after 2010 in your research topic, and you would say, okay, I'm doing my meta-analysis based on 2010, 2015, and you win because you have new papers. And as I said, if you include everybody, or include only some countries, or you include children, or you include adults, etc. So you should say, and you should also say about constructs, as they call. So it's theoretical constructs, and search was how you really try to find these papers. So you should say, if we're talking here about nightmares, and you should say, okay, it should be nightmares among women, nightmares among men, and that's how you find it, all the constructs. Yeah, in databases. Well, and then you should code these publications. Why you should code them? Actually, it depends on what you want to do with this meta-analysis, because if you want to run meta-regression, then you should think about that beforehand, what you should include, because if you say, okay, if I code different countries, then it will be like Russia, US, and other countries. So you would include this as a moderator in your meta-regression. That means that when you run meta-regression, that means you want to explain the dispersion of the variance in your effect size. So why the effect size is different, and it's systematically different in different publications. And you would say, okay, the effect size can be different because the study was in different country. Or you can also say, okay, the effect size can be different because of the year. Say in 1970 it should be lower, and now it should be like nightmares should be higher because of the stress. Or the design, was it experimental study, was it a non-experimental study? So that is how you explain the variance in the effect size. So that is why this coding scheme should be different for everybody. But I think this just about design and how the sampling is should be in every coding list. Yeah, it's if about coding, and usually there are more than, well, it's not usually, but there can be more than one effect sizes. Should I code them all? Should I not code them all? So it should depend on your topic, and should depend on your decision. I would say you can say, okay, I would select them all, or I would just say I will just calculate the average, and that is all. I would have one. So how many publications should be in your meta-analysis? So with 2 it's okay, but you will never publish that for sure. Well, it should be I would say for a good publication should not be less than 30, but I think with 20, with 20 publications it's okay, because usually in one publication there are more than one effect size. So what you report in your meta-analysis is how many publications you included and how effect sizes you have. So usually with 20 publications you have about 35 on average, I would say, effect sizes, and that's okay. So the problem, if you think about, okay, what should I do with all publications, usually have outliers, and statistical outliers. Statistical outliers can be with the sample size. It's usual problem. So usually have on average like 300, 400, 1,000 respondents, and one or two outliers with 20,000 respondents. What should you do? Because if you have 20,000 respondents as one publication, then your effect size will be close to this. Yeah, because it's really huge sample size. So you should do something with that. Usually you say, okay, it can be just the average sample size in your sample. You say, okay, I will truncate this to 400, and it's just the average sample size in my sample. Or you would say, okay, there is one maximal sample size, 1,000 respondents, and I will say, okay, 20,000. Now it will be 1,000 respondents. But you should do something with that. Another outlier might be with the effect size. So one effect size would be really an outlier. What should you do that? You should also truncate it. You should think about that. It's also like either you should think about the average or the maximal effect size you have in your sample. But you should do something with that. Okay, now it's the calculation. So usually you report, it's called forest plot, yeah. And usually what you usually see in any meta-analytical publication. And so these are different. So in this meta-analytical publication, you include only 4 publications. That's not a lot. So they report risk ratio. So this is effect size risk ratio. And they calculated the relative weight of the publications of the
What is it
samples.
based on? Sample size?
Yeah,
or the quality of the journal? Or
it's based on the standard errors. But usually, it's a standard error. The larger is the sample size, the smaller is the standard error. So that is usually the case, and so it's relative weight based on the standard errors. You see, that is how they report it, and that is the meta-analytical. And the thing is, sorry, I cannot really show you, but just pay attention with meta-analytical procedure. You pay attention to p-values, but it's not so important. With meta-analytical procedure, you pay attention first of all to the average effect size. And here you see it's 0.85%. But the funniest thing here is you see that if you pay attention to p-values, so the only study where p-value was significant was the third study. But if you see meta-analytical risk ratio, so p-value is significant. So that is kind of magic. But as I say, p-values is not so maybe important in meta-analytical procedure. The it's the effect size.
Does it show the p-value for the meta-analytical?
Yeah, it's here. I cannot show you, but it's 0.00. Because the summary is the effect size for meta-analysis. So that's how you report.
How is it calculated?
I will
Thank you.
just say it's not complicated. So the most complicated thing in meta-analysis is literature search. That is the hardest, really the hardest work. The effect size. So we calculate the effect size, and usually you use Pearson correlation. So one of the procedures which is known to everybody, and then you calculate. I don't know how to say it in English. It's Cohen's D and Hedges G, which is usually actually that is standardized. I don't know how to say it.
Разница средняя?
The
Mean difference.
standardized mean difference. Thank you. And what psychologists usually do, they just report either hedges G or D. So just that you find it easier to make a meta-analysis. And then odds ratio and risk ratio. But actually, you can do almost everything with meta-analysis. You can also calculate means or regression coefficients.
Betas, right?
Yeah. So you can do that. You can do that. And so with the correlation or Pearson correlation, you just report the effect size and you say if it's small or big, and if it's larger than 0.5, so you have a large effect size. As I said, this is Cohen's D, Hedges G. Sociologists usually don't know what is Cohen's D, Hedges G. All psychologists know for sure. Because that is usually what they report if they compare experimental and control conditions, and they usually report this Cohen's D and Hedges G. That is just the difference between means of the experimental and control groups, and you just do it by pooled variance of the both conditions. So that's how the formula looks like. It's as I say, it's just the difference between the means. Like if you have experimental and control groups, you just calculate the difference between these groups, and then you have the pooled variance. The pooled variance is just when you calculate both conditions. And this D and G, they vary usually from -3 to +3 because it's just in standard deviation. So the thing, what you report with this D and G is just how they vary in standard deviation. So usually the standard deviation is from 3 to 3, from -3 to +3. So it also varies from 3 to 3. But if it's 0.8, so it's a large effect size. Another way to look at that, because usually it's difficult to understand, but if you say, okay, what is the large effect size, and you say the last column, if you say, okay, the D is 2, what does that mean? That means that they are different with 81%. The conditions, experimental and control conditions. So that is a huge difference between control and experimental conditions. It varies whether you report D or G, but D is biased with small sample sizes. So people prefer to report more, I would say, Hedges G. It's just based on D, but with some correction. So but the logic is just the same as with D, Cohen's D. Well, other and I will not talk about that. You can just check. It depends on what effect size you want to measure, and you can report odds ratio, risk ratio, means whatever. You just have to be careful how you can calculate that in meta-analysis. So, okay, how you should calculate that in your meta-analysis? So you choose your statistics with which you just report your effect size. And then from each publication you calculate the effect size on each publication. And then you calculate just the effect. It's kind of very easy what you should do. The effect size, the problem with one of the problem you can usually face is that there are not such statistics for it. There's no such statistics as a Pearson correlation, and you want to measure Pearson correlation and like 5 articles report and 15 not. So what you should do? The answer is that based on other statistics, you can just calculate the statistics you want to have, and there is if you Google effect size calculator, you will find a lot of effect size calculators to report if you have F and you want to report T or I squared. Based on that, you can calculate your statistics you selected. So another problem which you usually also face is that there is no sample size based on which you can calculate different statistics, or there is something else. Usually you write to authors, and that is the usual case actually. Like 30% you would just write. I also did a meta-analytical paper, and I wrote to almost everybody. Yeah, it's just usually the case actually. So it's fixed effect or random effects model. So that is how you should calculate the effect size based on your publications. And there are two answers here: use fixed effect or use random effects. So the fixed effect that is usually is not applied in meta-analytical. So it's very rarely used. Very rarely used fixed effect, because you think that you should think about that as there is no systematic difference between publications. There is just an error. There is just a sampling error, which you say, okay, with higher sample size, with larger sample size, there is lower standard error. Based on that, that is why it's called fixed effect model. So it's just singular. There are no effects. There is just one effect. And the random effects model is that there can be millions of effects. So they can be really different, and there is a systematic difference between these publications. And with random effects, what you usually do is the meta-regression. So that is, usually all publications in meta-analysis is meta-regression, because what you want to do with random effects, you want to explain the variance between the publications. So that's
second level variance.
Yeah, so that you include moderators. That's why you should code that, and why you should have hypothesis why the effect size can be systematically different. And now I will explain it. So this is the fixed effect model. So what you think when you have this fixed effect model, you think about that as there is one, and as we call it in statistics, there is just one true effect size, true, yeah? And so why it's different in different publications? Because of the error, standard error. So smaller error or higher error, but it's just the same, one effect. Yeah, it's just the same. So in the fixed effect model, what should you do? You calculate the effect size for each publications you have, and then for each publication you calculate the weight. So the weight is easy. Is just how to say it? One standard errors squared. So how?
It's the inverse of the variance.
The inverse, yeah. It's the inverse of the variance. Yeah. So you see. So the logic, as I say, it's just one fixed effect. So the weight should be like that. Larger sample size, lower weight, because larger sample size, the standard errors are higher, right? So the weight should be lower. So that is just very simple logic. And then based on that, these weights, you just calculate the effect size. So this is the weight and effect size for each publication, and just sum of weights. Very easy, very easy. and then you calculate the standard error or the effect size, and then you report it. Just very, very easy. So the hardest work, as I say, is just literature review. The calculations.
So it's grand weighted average.
Yeah. It's just that. With random effects, it's a little bit more complicated. But as I say, it's they suggest with random effects, you suggest, okay, there is no one true effect. There are different effects, and they can be systematically different. So, like with different publications. And what you want to measure with random effect is and explain that is the main thing you explain. You explain the systematic difference between publications. So that is usually the case with meta regression. Yeah, I just told it. With what is the hypothesis with the fixed effect and random effects model? So with the fixed effect model, the null hypothesis is just the effect size is 0 in each publication. So that is with the random effects, you explain the variance between the publications. So you suggest or you hypothesize that the variance between publications is 0. So that is how your null hypotheses are different with the fixed effect and random effects model. So when you should apply fixed effect model? So usually it's if you have very similar research, like if you will have based on world value survey, you do a meta-analytical procedure. I think you should have fixed effect model because there are almost no differences. You should theoretically explain in your publication why you think you should stick to fixed effect model or why you should stick to random effects model. Another, the third goal, if you apply fixed effect model, is that okay, I want to measure only those who were only in world value survey, and so I should not think about other people. So with random effects model, you can extrapolate to other subjects, and with that is that you cannot extrapolate. But if you have identical surveys, I think you should stick to fixed effect model because there are no, I would say there are no reasons you should stick to random effects. Yeah, with random effects model, with random effects model, it's usually researchers use, and you should. What you should explain with that is the heterogeneity. So with random effects, you think about that as explanation of the variance, as I said, and you should calculate the heterogeneity, first of all. So heterogeneity is with quite easy formula, weights and then effect size for each publication you have minus the mean effect size. So it's quite easy, and you compare to chi-squared, and the null hypothesis that there is no heterogeneity. So
it's almost like variance, except it is weighted.
Yeah, exactly. Mm-hmm. And so if it's higher than chi-squared critical, then your publications are heterogeneous. So there is a heterogeneity in your publication. You should explain it. If there is heterogeneity, you should explain it. So that is the case. Based on heterogeneity, you calculate tau. So tau is just the between group, is it between?
Yeah, between group.
Between group variance, and it's also very easy. So with the random effects model, if you remember, with fixed effect model, it was just standard errors, and with with random effects model, you should explain the variance between the publications you included. So in the weight, you include the between group variance. So quite easy. And so based on that, you calculate the weight, and based on this weight, you calculate the mean effect size. And yeah, based on that, you just report it. How it is different. So if you say, okay, I have the same data set of publications, if I apply fixed effect model and if I apply random effects model, how it can be different. So if you, I'm sorry, maybe you can't really see that, but since you in the random effects model, you have not only the standard errors, you have also tau squared. There is a lower weight. So for instance, if you see, maybe you don't see, but the donut, this is 1, 2, 3, the fourth publications, if it's in fixed effect model, it was the relative weight that was 39%. That's really huge. So it's mainly, so the effect size is mainly based on this publication. So that's the main point. With random effects model, the relative weight is only 23%. So it's just lower than with the fixed effect model, because because we include tau squared. So that is the point with the random effects model. Well, you should also report, before you run meta-regression, you should report I-squared. So what you usually report with random effects, you report Q, you report tau squared, and then you report I-squared. So I-squared is just a percentage of the between group variance to all variance.
For those who are familiar with multi-level analysis, this is similar to ICC.
Mm-hmm.
Interclass coefficient.
Interclass
correlation
okay,
coefficient.
So I will show you, and it's it looks like that. So your total variance is 100%, and what is I-squared is the proportion of the between group variance. Yeah. You also have the standard errors or variance within the publication, but you also have the variance between publications. And with I-squared, you report these variance. Before you run a meta-regression, if I-squared is higher than 70%, then there is a reason to have a meta-regression.
17 or 70?
70. Wow. Usually it's high actually, I-squared. So there is really usually.
That's really the proportion of the variance between publications, between studies, in the overall variance. Is that?
It's huge.
It's huge, 70%.
But it depends. You see, 75%, 50% is mean. Sure, you can run a meta-regression if it's 50% also, but you usually have higher. Mm-hmm. There is a trick actually. There is a trick that sure, if you have lower number of studies, I-squared is very high. So if you have 3 studies, your I-squared will be 100%. But sure, if you include more, then maybe 50% to have I-squared 50% is a really good reason to run a meta-regression. So the I-squared sure depends on the number of studies you have. So I'm almost done. It's just if you run meta-regression, so what you should think about. So if you run meta-regression only in the random effects, when you want to explain the heterogeneity between publications, you include it in your sample. So what you should do, you include moderators. That's very important. You should think about these moderators. So it's very hard job, because it can be that the authors do not report moderators, so you should ask for these moderators. It is really hard job, and you should find the moderators in each publication you have. So the more moderators you have, more job you have. So if you have really a lot of moderators, say 15 or 20, there will be a problem with multicollinearity. So sure, check for multicollinearity, and if you think there should be this and this moderators, but they have a high correlation, you should think about that. And you should also report if you found multicollinearity and which moderators you excluded and why. So what you should report in meta-regression is the Q, tau squared, and also R squared, because with the R squared you just report what proportion of the variance you explain with your moderators. So sure, the higher R squared is, the better is your meta-analysis, and so the happier are people who read your meta-analysis. So R squared is very important. So with meta-regression, what you should report, it's very important to report it, and you should report, as I said, literature search, how you were searching, and what databases you were using, then inclusion criteria, so what you included, what you excluded. So you also have a bunch of papers which you excluded. You should report why you excluded them, so that other people who read it understood why they don't see these papers in your meta-regression. And then you should report moderators if they had some problems with multicollinearity, if you excluded them, why you excluded some of them, etc. And so meta-analytical procedures, so that is just explanation of what effect size you calculated and why. So that is the main problem. So with the software, as I said, it's not complicated to calculate the effect size. It's just literature search, which is really really difficult. But if you want to use some softwares, there is some specialized softwares. For instance, comprehensive meta-analysis, which is very good. But I think you can use it for 30 days free of charge, and then you should pay. So if you have a publication and you are ready with your meta-analysis, you can just use comprehensive meta-analysis free of charge. It's very good. I like it because it has really very good graphs. It's very easy to, very user-friendly, I would say. I just used it also once, but not for my publication. Mix for meta-analysis, I don't know, I haven't actually tried it, so I don't really know. So comprehensive meta-analysis is very good. But I used R metaphor. It's maybe, I'm not very good with graphs in R, so the graphs in metaphor are really bad, but it's very easy. So I'm not very good with R, but even I was okay with that. So it was very easy to do it with metaphor. The package is really good. And then Stata, I have never tried it. Or with Stata, with the SPSS, it's you can do it with fixed effects, but not really meta-regression. So it's but if you have fixed effect, it's okay to use SPSS. So I think that's it.
Thank you, Aigul.
I'm almost sorry.
Okay, now it's time for questions, for comments.
I have one question about truncating super large samples. That's a big way of interfering with your data set, and what is the rationale? I mean, how do you justify this? So this is perhaps one question. Another thought that I had is that when you do meta-analysis, perhaps it's a good idea to distinguish between journals published rated in the first quartile and journals rated in the second quartile and the fourth quartile, because you know that the quality of journals, you know, may also be a factor that should affect the weight you attribute to publications. But apparently nobody does this. They take all publications, even unpublished ones. You mentioned even unpublished ones, you know, at their face value, attributing them equal size in terms of quality. So the only issue is then the sample size. But then you truncate. In certain cases, you decide you can truncate sample size, which I'm not sure how to justify.
Thanks for questions. With the first question, I don't really know if it's. I think it's a good way to truncate it, because otherwise, if you have really huge outlier, I mean, I say when it's huge, it's really huge. For instance, I really have one outlier in my meta-analytical procedure, and the weight is higher with this, so I decided just to truncate it. I don't really know. I don't really have a good solution here. Should you truncate or you should not? I think you should if it can have, if it's just one, and you are not sure if it's a good thing or not. I will truncate it. Well, but that's my point. So and when I saw several publications which also usually truncate, do something with the outliers. So you should, if you have outliers, do something with that. But I don't really have a good solution for that, so I don't really know. With the second question, which was about journals. Oh yeah, I like that question. But it's the reason what you say about is the correction weights. Yeah, there is actually some papers do that. So they say, okay, there are different publications. So that is a problem with garbage in, garbage out. Editors talk about that now, saying if you have bad quality publications, that you have bad quality meta-analysis, it doesn't really help with that. And so one of the solution is having these correction weights. But it's your choice how you should do that, and you just should explain that how you do that and why you're doing that. But there are papers which do that.
Thank you.
Well, I've just got maybe some clarification question, but just let's imagine, for example, I make a survey of trust, and there is just, I can say that the research increased like in the 2000 or something like that, so I take this part, and there is huge amount of publications, and I can at least just call 30 that are mostly cited, and then I'm to somewhat pick out only the ones that are in my sample, or how do I perceive it?
So the main thing is that when you do your meta-analytical work, so the main thing is that you include papers, and that is a representative sample of all the universe. So, well, better all papers which can be in the universe, but the main thing is that you have a representative sample of the universe, and based on that assumption, so that is just assumption, that is a representative sample, but you should prove that, and you should prove that with your inclusion criteria and with your search strategy, how you were searching the literature, on which databases you used. Like with Google Scholar now, it's if you use like databases, and if you use Google Scholar, and with Google Scholar you have thousands of pages, and usually what the authors report saying, okay, we were up to 300 pages of the Google Scholar, and we finished it because it was just nothing there. So and that means that the assumption is that okay, Google Scholar is the universe of all articles published and unpublished, and if I check them all, so that is that will represent your research question. And that means that it should be unpublished as well. So that is one of the, just to not to have the publication bias. And usually what you also report with in your meta-analytical paper, you have you report the effect sizes of all your publications you included. And if you show that there is no publication bias in your sample, that is very good. So you prove that there is no publication bias. If you do not have publications with insignificant effect or small samples, then you should do something more, not to have this publication bias. So that's the main.
Thank you. But it's always sampling, so I cannot just like justify that I want to
not really.
more read.
It's if you just report 30, well, if you report only 30, you just say that it's meta-analysis of these 30 papers.
If I may ask another question, can you give me an example of a moderator variable that would explain variance between publication? Is it like nationality of the author, or what kind of moderating variables people use?
Well, it can be different because the question can be also like if you ask about happiness, you can there can be different effect sizes, and the problem is that there are not so many studies which ask the question just the same way. They can ask about satisfaction, they can ask about happiness, they can ask about mood. They can ask about anything else, and you say, oh, okay, maybe the difference in the effect size is just in the way the question is asked, and you just code, okay, if they ask mood, or if they ask about satisfaction, or if they ask something else, or if it was experimental study or non-experimental study, if it was reported by respondents, or it was reported. It's, for instance, it's very important for children because it's if it's reported for among children, or it's reported by their parents or by teachers. So it's also a different explanation.
Okay, thank you.
So that means that in meta-analysis we are working with theoretical constructs, and we can use different ways of measurements for these theoretical constructs.
And you can, and with that you can explain why there is a variance between between the papers, and that will be a very good finding because you explain why the effect size can be different. So, yeah, because with this, if you run meta-regressions, and that one of the advantages of meta-analysis that you can find some effects which you would never think about that. And after that you can say, okay, there is something here, and you can have another paper. But with meta-analysis, I say, and I continue saying that it's very good. You are very well cited with the meta-analytical works. So do your meta-analysis.
Are there questions in St. Petersburg?
We have a question.
Oh, sorry. There is one more question here in Moscow. Could you come a little closer so that people would hear you in the other city?
My question seemed to be stupid, but still I want to ask one thing. So, as I understand, you can solve one problem which you face using...
Включите нам камеру.
Don't know how to.
А что такое?
Can try.
Камеру нужно включить.
using different things using different areas in meta-analysis. So,
Oh, sorry. Can you repeat your question?
Well, you can solve one problem using different formulas of meta-analysis, as I understand.
It's I understand. Now I understand. You say about different statistics of the effects. Was it this
Yeah.
the question of the or not really?
Yes, you understand.
So it depends on or what you want to report. So usually if you have like the table 2 by 2. So if you have experimental and control condition. So you can report, usually psychologists would report hedges G and coins D, but then you can change your statistics. You can change your statistics to a different one. Report odds ratio or report something else. Or if you say I'll report means, that also can be done. And with means, you usually explain the variance, why there should be different means in your groups or in your publications. So usually it's your choice, but think about your readers. So it can be also different in different. For instance, sociologists usually don't report D and G. They would rather report odds ratio. And for instance, with medical, they would report risk ratio. But for instance, odds ratio is better for us because we are better with odds ratios. And with DG, not really.
All right, so
Just a small clarification question about the specifics of using this approach in social sciences. In sociology and political science, like in social sciences in general, we also have qualitative studies, like case studies, so on. And when we are looking for, when we're researching, so should we just exclude them if they just do not report what we call here the effect size, but they can report just kind of, association between variables and so on. So, in this case, they're just excluded, and we are looking only for quantitative studies, or we should somehow recode it, and so on.
Well, sure, if they don't report statistics, then you can't include it because there should be some statistics in your in the publication. But there can be some statistics in qualitative studies. Then you sure can report it, and it will be really good.
Okay. Any other?
I'd like to pose two questions. The first one is, could you say, please, in which disciplines is it more common to apply meta-analysis? Maybe you do know. And my second question, which I think is a natural one, could you please tell us a bit more about your own experience with meta-analysis? Thanks.
Yeah, thanks for questions. The first question was about when it's usually applied. It's usually applied in psychology. Among social sciences, psychologists are much better with meta-analysis. And recently, I was reading Igor Kohn books, and he was such a big fan of meta-analysis, and he was even explaining, it was very funny to read it, he was even explaining the statistical procedure of calculating the effect size in his autobiography. That was very funny. And usually he said, well, do meta-analysis, so that's the greatest thing you can imagine in the social sciences. But usually sociologists do not report it. I think there should be changes there, but if you say psychological works, then a million of meta-analytical procedures and papers. I was, if the second question was about my, it's not published now, but it will be published, and it was just because I'm doing online service, and with online service there is a good bunch of meta-analytical works, and what you usually explain is either response rate, so why response rate is higher there. So it's usually you run meta-regression with explanation of why response rates were different, and with that you can do that with each survey mode, and you can also compare different countries and different studies and so on. So I was doing that with mobile web service and explained the variance between that.
Okay. Well, Aigul.
Any other questions?
Oh,
No.
then let's thank Aigul again for opening our seminars this academic year.